Hey guys, it's Mr. Wooten. Just making a quick video to kind of help you get through these outcomes, work through these practice problems, and hopefully be preparing for your final exam here in a week or so. So what I want to do is I'm going to start with the very first question from outcome 1, talking about reasoning and solving problems involving inverse variation. So the first problem talks about this guy, Juan. He's driving to Charlotte to visit his grandma. He's driving there at 60 miles per hour. What we're asked to do is come up with an equation to relate the distance to the time that it takes to get there, right, if he's traveling at that speed. So the important information we have here, we know that his speed is 60 miles per hour, and he's going to keep that speed constant. So what we need to do is we just need to figure out how to relate d, the distance, to t, the time it takes to get there. So if we can do that, pretty straightforward. Now, think about this. The longer he travels, if he's going at 60 miles per hour, is his distance going to increase or decrease? It's going to increase, right? Clearly, the longer he travels, he's not going to be going a shorter distance. So this is not an example of inverse variation. This particular problem is just trying to show you that you don't assume something is inverse variation right off the bat. You got to think about a problem. Inverse variation would be such that the distance would increase as the time decreased, or vice versa. As the time increased, the distance would decrease. So this is actually an example of direct variation. So in direct variation, we see this relationship happening. We see that the longer he travels, since that is usually going to be our independent variable of time, the longer he travels, if we multiply that time times 60 miles per hour, his speed, that will give us the distance. For example, if he travels 1 hour at 60 miles per hour, he's going 60 miles. If he travels 2 hours at 60 miles per hour, he's going 120 miles. So this is the pattern we see in the relationship. Now this could be represented in one different way, and that is to take this equation, and if we wanted to solve for the constant that is going on in this problem, the constant is the speed that he's traveling, 60 miles per hour. So if I divide both sides of this equation by t, then this side I'm just left with 60, and over here I have d divided by t. So his distance divided by time is equal to 60. But remember, for inverse variation, you always multiply the two variables to get your constant number. And we'll call that k. That's the constant. And this is that constant of proportionality. So for inverse functions, anytime you multiply the x and the y variable, you always get your k value, your constant of proportionality. Right? So this is actually not an example of inverse because we see we're not multiplying but actually dividing the two variables. And that results in the constant of 60 miles per hour. So this is the first question. It's actually an example of direct variation, not inverse. So hopefully you got this one correct and move on to the next problem.